Okay, hello again. Today is gonna be lesson 3 and we will be discussing again vector analysis in 2 dimension. So I have a question for you as you guys asked me. Here's a force. I'm gonna call it TAC 20.6 degree. Here is force FD. This is your y-axis. Here is x-axis. Here's 60 pound x-axis, y-axis. Here is 40 pounds, and here's 60.3. Let me just fix this, and let me read the problem statement for you. Let's say you're assuming there's not really real problem statement, because I feel like this is just wasting time, sort of speaking. But if you have a system like this, you could pretend this system is going to be like you're holding something, or like, for example, a connection, and then there's like a rope or a cable here, cable there, and you have a cable here. You want to put that cable FD, and you have the weight of your body, or self-weight is 60 pounds. Obviously that's not you. And then you've got 40 pounds here, and you're looking for designing this system to make equilibrium, knowing this angle and knowing this angle. So the question of the problem statement will be find FD comma TAC. So this is what we call the free body diagram. So here's the problem statement, or the problem sketch, and here's your free body diagram showing what's exactly the unknown versus the known. And you could obviously label them, you know, in conformance with the problem. So this is kind of like reversed. I tweaked the problem and I asked, what would be the force here and the force here? You're going to have the same philosophy. You're going to sum the force in the x component equal 0. You've got TAC, 40, and FD, all of those on the x-axis. So I'm going to start with FD because it's easy. TAC, it's going to be positive, the projection of TAC on the x-axis, right? And in order to get this component, we're going to do what? We're going to do sine. We're not going to do cosine. And same thing here, we're going to do sine. So we're going to have plus TAC cosine 20.6 minus 40 times sine 60.3 equals 0. That is what we're going to call it equation number 1. This is going to be equation 1. And then you're going to have equation number 2. Sum of the forces in the y, positive is up, equals 0. In this case, you don't have to think about those, so no FD, TAC cosine 20.6, and 40 cosine 60.3, and then you've got minus the weight 60 equals 0. And again, I'm not teaching you math here, So you should be able to solve two equations, two unknown type of system type, I think. So you've got FD equal TAC equal. FD was 19.7 pound, and that's 42.8 pound, and that would be your final answer. So my point of this question is, it could be a resultant. Find the resultant of this system. You could solve it once you find out what is the unknown or what are the unknowns. Or it could be asking what are the forces that need to be in those two members in order to make the system in equilibrium, steady state. So I hope that makes sense. Equilibrium versus resultant, both of them will be sort of identical, except one would be asking for the resultant if everything is known, and when it comes to unknown or equilibrium, you're looking for particular members or particular internal forces or external, if that makes sense. Let me know if this video was helpful. Comment below please if you have any questions, and I will see you for lesson 4 to do 3-dimension analysis for this upcoming week. I will sign out for now, and we'll catch you later. Peace.